we're checking the answers across the top on the inside. The equation that you were supposed to use is that all of the interior angles add to equal 180 degrees, right? However, the pictures also involved linear pairs. Like here's a straight line. There's another line, a segment, I guess you could say, that is creating two angles. So if you notice, you have an angle here. Well, hold on. You have an angle here, and then you have an angle here. Y'all see that? So those two angles are adjacent. They form a straight line. That makes them a linear pair, which means they add up to equal 180. And that's going to help you when you're trying to figure out the measures of the angles. Another helpful tip, when you answer the question with the measure of the angle, for instance, ACB, you are reading the angle with 3 letters. That is probably the most challenging part because people tend to look in the wrong corner. If it's A to C to B, then the corner is right there. Okay? The 51 has nothing to do with it. The 47 has nothing to do with it. We're trying to find this angle, right? Now we're going to use the fact that this is a what? A triangle, and we know 2 angles. So 180 minus those 2 leaves you with 82. If you write 82 right there, and then try to answer the next question, it's harder. You need to go to the picture and take notes in your picture, because then that's going to cue your next train of thought, like, okay, now I know this triangle's done. Obviously, I'll have to find this angle and this angle. And since I wrote 82 right here, that's my clue that I can find this angle B, C, D right there, because it has to add to 180 with the 82, right? So it becomes like a puzzle, which ends up being what, 98? So this is 98. Now again, we have a triangle where we know 2 angles, we're missing the third. It's as easy as doing what?
Adding 98 and 48 minus 180.
Were you going to say subtracting them off 180? Same thing. Totally different ways to get there, but it'll be the same answer. And you should get 34, right? Did you get it? This is probably the very first lesson where you're really having to be a problem solver, okay? Math is easier if you can wrap your mind around being a problem solver. You have to be analytical. Like, what am I looking at? What do I know? What do I need to know? What can I find first? Questions like that, okay? And I'm hoping to train you to be that way. When you get over here, there is a lot going on. A lot, right? You should have started with the one you know the most about. Odds are you went right here. Did you start there? Because I know 2 angles. I can find the third. What'd you get for the third? 20. Yeah. And then another thing that's a helpful tip when you have these problems where there's a lot of questions based on just one picture, it's easier if you just go to the picture and start trying to fill stuff in instead of sitting here trying to read the angles. Ignore this and just go to the picture and work with the picture like a puzzle. Then when you're done with the picture, then come over here and start trying to find the angles, because you'll have the picture labeled. So it'll just be a matter of reading the picture. Does that make sense? So don't Don't use the questions to guide you. Use the picture, fill it in, and then when you're done with the picture, then answer the questions. So, like right here, we filled this triangle in. Now you could go several ways here. My mind saw that that's a straight line, which means we have a straight angle, which measures how much? 180. And I saw if that's 20, then this would be what?
160.
160. Right? Then the next part, you might have jumped around a little bit. In terms of going to what you know, look at this corner. There's a lot going on in this corner. There's a 25, a 30, and then what's that square? Square's 90. Do I have enough to find this?
Yes.
Yes, I do. This is that part plus part equals whole. You got 25 plus 30 plus something has to equal 90. So you could do the subtraction method and say 90 minus 30 minus 25. And then you would get what? 35? Now notice you have a triangle with two angles that you now know. It's this one right here. So what's angle G going to measure? 35. So you didn't have to go here. I'm just going to see if you remember. Can you tell me what type of triangle that must be, since it has two 35-degree angles in it? Yes. You're going to learn that however many congruent angles matches the number of congruent sides in triangles, only in triangles. Okay, now if we're looking, now there's a lot of places to jump around here. Look at this cluster right here. I'm going to box it in. That's two lines crossing, and this is 100 right here. What's the vocab word that comes into play here? Vertical angles. If this is 100, follow the bow tie to the other side. What would this be? 100. And these are linear pairs, right?
Yeah.
So if this is 100, what's the one next to it? 80. Right? Linear pair, 180. And if this is 80, what's this? 80 because of vertical angles. When you have a pair of vertical angles, if you know a single one of them, you can find all four. Okay? Every time, every day, every problem. If you have two straight lines crossing, it creates vertical angles. If you know one of them, you can find all four. And it's just a matter of finding the congruent one, the bow tie, and then doing the 180 minus. So, if this is 100, I'm going to turn this C into a 100. And then I guess I'm going to put C. This is really crowded. I guess I'm going to put C right there. And then I'm going to mark 80 as best as I can. It's getting crowded. Here and here. Now I see two triangles where I know two angles and I'm missing the third. You've got BCF and you've got CEF. That's 80 and 30, that's 110, so this must be 70. This is 125. If you subtract that off of 180, do you get 55? Is that 55? Yeah. There's one angle you struggled with, and it was that one right there. And that's because it's not in a triangle. Do you notice how it's in a four-sided figure? Which is totally different. Now, I was not expecting you to remember this. How's it going? So it's kind of like this, I guess, a little bit. Maybe. I mean, it looks a lot better. But something like that. We're going to pretend. I could just hold the paper. This is 50. This is 160. And this is 80, right? Okay. In middle school, you learned this, but I know you've slept since then. Do you remember how many degrees every four-sided figure adds up to, the angles? All right, no biggie. If I have any four-sided figure, I'm going to try and make it goofy. Here's a goofy one. Any four-sided polygon. Polygon means the edges are straight, okay? No curves. Any four-sided polygon, the angles add up to, yes, because if I draw a single diagonal, if I connect any single diagonal, I now have two triangles that each measure 180, and what's 180 plus 180? 360. So this quadrilateral adds to 360. On your paper, because you do have a little room, I want you to draw a big arrow to that quadrilateral. I want you to write quadrilateral, and we're going to abbreviate here, angles add to equal 360. That's what I want you to put on your paper. Quadrilateral angles add to 360. Now we can find that fourth angle, and you should find it to be 70. So see, I just filled in the whole picture without looking at a single question. I just saw the picture as a puzzle, and I started filling it in. So I would like you to try to adopt that same technique, because it does make life a lot easier. Then you should have just gone in to read these angles. You do have to read them carefully, trace it carefully, make sure you're looking at the correct corner. But you should have gotten the following answers. The other nice thing about if you just work the picture first, then the question second, what if you had your picture entirely right, but your questions were wrong? Then I would be able to say, okay, you're doing the math right, you're reading the angles wrong. So, you know, that's also a possibility, which is why it's important to show all of your work, show every answer, because then I could tell you, you know, if that was the case. All right, close the flip book and let's look at the front. We have another important aspect to learn, and it's very simple. However, people tend to forget it because it does not come up a lot. So I'm going to give it a nickname, a silly nickname. So hopefully you'll remember this conversation that we're having right now. Here is the fancy name. It's called the triangle exterior angle theorem. That's what it's called. Ms. Holcombe, and y'all have to help me with the spelling. Ms. Holcombe calls it the bougie theorem, bougie angle. How do you spell bougie? I don't either. Bougie, if I understand that slang word correctly, means extra, like, you know, fancy or extra or too much. I call it the bougie angle because it's just kind of like too much. Like, we shouldn't even need this theorem because you should be able to deduce this through the linear pair. You shouldn't need the theorem. So I call it the bougie angle. So anytime I say to you, oh, it's a bougie angle, you need to remember this, okay? All right, so what exactly is the bougie angle? So look right here, I'm going to ease you into it. What shape is this? A triangle. And the angles of a triangle add up to 180. So 45, 95, and green add to 180, correct? You don't have to highlight that. Okay, now what is this? Linear pair measuring 180. So did you notice the triangle adds up to 180, the linear pair adds up to 180. What piece is in both of them? Say green. The green, right? The green angle was in the triangle sum. The green angle is in the linear pair sum. So the bougie angle theorem says, you know what? Take the green and, or just choke. Take the green angle out. And if you focus on the fact that this and this angle added together will always equal the bougie angle. And that's, I'm going to show you the math behind it. I'll show it to you right now. Did she give it for you? Yeah. You're not going to use it? No. Won't it make you feel better? You don't think so? Water is really helpful. That was just a flyer they told us to pass out. It has events, I think, in Fort Oak before coming up. All right, so let me show you the math behind it. Let's go ahead and find this angle right here. So 180 minus 45 and 95. Somebody tell me. 40? You with me? All right, so you don't have to write this down. Just watch. So angle A plus angle B plus 40 equals 180, right? All right. Notice the 40 and the x are a linear pair. So x plus 40 has to equal 180, correct? Yes? Everybody agree? Do you notice how both of these equal 180? With me? So, do you recall something called substitution? Learned it in Algebra 1. Where you're saying, like, if x plus 40 equals 180, and a plus b plus 40 equals 180, then does this equal this? They're both 180, right? All right, so watch. I can set them equal to each other. Watch this. Notice I just set them equal to each other. Yes? Now I'm going to get rid of the 40. Here. Come to the other side. Here. What happens? What am I left with? Which is what I just showed you. You see it now? This angle plus this angle will equal the exterior angle every time. Could you still solve the problem without having the bougie angle theorem? Yes, if you can just look at this and say to yourself, well, that's a linear pair. If I just found the 40, then I can find x to be 140. I personally find that easier. If you go that way, that is fine. However, there will be a practice problem or two where you don't have enough info to be able to say that. Like, instead of it being plain numbers, it might be 45x and 95x plus 1. And in that case, you can't find, you know, you don't have enough info. So the bougie angle theorem does come into play, but if it's a triangle where you have just numbers, you really don't even need it, honestly. So now let's come right here. This is just more practice with what we were doing. So notice this triangle right here. What type is it? It has two congruent sides, so what is that?
So minus 80.
And
After that, divided by 2.
yes, why?
Because they're equal the same.
There you go. So remember we said yesterday that the base angles of an isosceles triangle are equal. Now the 92 is not a base angle. Up here the 50 was a base angle. So it was like, okay, well if that's 50, then that's 50. But that's not the case here. This time it's the angle in the top of the roof, which means we got to do 180 minus the 92 to know what we're left with. And then we know that the both of them have to be equal, which is why he said divide by 2. So what did you get? 44. My pen is too much for this little picture. Alright, and if this is 44, how does that connect me over here? There you go. I want you to draw an arrow and I want you to write vertical. It's going to help your mind to start recognizing when you have vertical angles. Okay? And then now we can find this angle right here to be 36. Alright, let's flip it open. And we're going to do these practice problems. I want to do the one with you in the middle. This one right here in the middle. Notice the setup. It's a bougie angle setup, okay? This is bougie. Bougie. Which means the two angles that are not touching the exterior angle. This is the exterior angle right here. This is on the outside. It's like where they were drawing the triangle, and instead of stopping the drawing at the triangle, they just kept going. So you have this exterior angle out there. The bougie angle equation is the two angles that are not touching the exterior one add to equal the exterior one. So this plus this will equal that. So we've got 4x minus 5 plus 8x plus 1 equals 134. And that's your equation. Should solve it, and you do get a decimal, but it's pretty. It's 11.5, so don't think you're wrong. But if you are wrong, fix it. Keep going. I was just checking in. Good. I would love for you to do these two practice problems that are left. I'm going to guide you on this one a little bit. This picture looks like what was on the front, but the questions are slightly a little different. It is asking for a couple of exterior angles. So let's just fill in the picture with what we know. Which triangle do I know more about? The one on the left or the one on the right? The one on the right. Remember the phrase, go to what you know. Go to what you know, because it makes life easier. So we know that this triangle has a 30 and a 90, which means I can find the third angle by subtracting that off. And do you get 60? And how is the 60 going to play a role with the triangle on the other side? There you go. Two straight lines means vertical angles are formed. So if that's 60, using the bow tie mindset, come to the other side of the bow tie, and then that would be 60, which means this is 90, which means this is 30. Now, when you go to answer the questions, though, I don't remember if it's one or two of them are exterior angles. So let's look at it. You got HJI. So that's HJI, and it's the corner. So that would be 60. 60 would go here. Now you've got KJL. KJL, it's the corner. That would be 60. Yeah, we got HJK. So H to J to K, you are absolutely right. And that is actually out here, which feels really weird because in my opinion, you got two triangles. Why are we worried about the outside? But there's two ways to get it, and I did not use the bougie angle. I just noticed that it lines right up with the 60. Right? It's a linear pair with that 60. So what does it have to measure? Well, yeah, so the total has to measure 180, so it would be 120. So that would go there. Then we got IJL. I to J to L, which is another exterior angle, but you could use the vertical from the 120. So it'd be 120. All right, I'd like you to get with a neighbor and answer the questions on the last picture. It will give you a domino effect once you start filling it in. And I would say start right here. Find this angle. Notice it coincidentally pairs in a linear pair with the 145. You do have an isosceles triangle in here, which means you will have face angles congruent. This will be congruent to this, so once you find that, it's going to help you, okay? All right, finish answering that.